factors and multiples. Multiples. I will explain this topic with the help of some examples. Let us take the number 15 as an example. Let us see the numbers which when multiplied gives a product of 15. 3 into 5 is equal to 15. 5 into 3 is equal to 15. 15 into 1 is equal to 15. 1 into 15 is equal to 15. Here 1, 3, 5 and 15 can be multiplied by another number to give 15. We say that 15 is a multiple of 1, 3, 5 and 15. Study the given grid. This table can go on endlessly. Each row of numbers corresponds to the multiples of the numbers in the first column. Multiples of 2, 3, 4 and so on till 10 are seen in this table. Let us see some more examples. 5 into 6 is equal to 30. Here 30 is a multiple of both 5 and 6. 2 into 1 is equal to 2. Here 2 is a multiple of 2 and 1. 3 into 1 is equal to 3. Here 3 is a multiple of 3 and 1. From the above examples, it is clear that every number is a multiple of itself. Now look at the second column in the table. It shows that every number is also a multiple of 1. Can a multiple of a number be less than the number? Let us verify this. Take an example. 5 into 6 is equal to 30. 30 is a multiple of 5 and 6. It is greater than both 5 and 6. Hence, a multiple of a number is always greater than or equal to the number itself. Odd and even numbers. A number which is a multiple of 2 is called an even number. Thus, 2, 4, 6, 8 and so on are called even numbers. A number which is not a multiple of 2 is an odd number. 1, 3, 5, 7 and so on are called odd numbers. Factors. Look at this table. 3 into 5 is equal to 15. Both 3 and 5 are factors of 15. 15 is a multiple of both 3 and 5. 8 into 7 is equal to 56. Both 8 and 7 are factors of 56. 56 is a multiple of both 8 and 7. 6 into 7 is equal to 42. Both 6 and 7 are factors of 42. 42 is a multiple of both 6 and 7. Let us try to find out the factors of 24. 1 into 24 is equal to 24. 1 and 24 are factors of 24. 2 into 12 is equal to 24. 2 and 12 are factors of 24. 3 into 8 is equal to 24. 3 and 8 are factors of 24. 4 into 6 is equal to 24. 4 and 6 are factors of 24. Therefore, the factors of 24 are 1, 24, 2, 12, 3, 8, 4 and 6. When we multiply any two or more numbers, we get a product. The product is a multiple of each of the numbers multiplied. Each number is a factor of the product. Prime and composite numbers. First, let us write the factors of numbers 1 to 20. From the table, it is clear that 1 is a factor of every number and every number is a factor of itself. Look at the table carefully. We have encircled number 2, 3, 5 and 7. Do you find anything common in those numbers? Yes, each of these has only two factors, 1 and the number itself. Numbers which have only two factors, 1 and the number itself, are called prime numbers. The numbers 4, 6, 8, 9, 10 have more than two factors. Numbers which have more than two factors are called composite numbers. Note that 1 is neither prime nor composite. It is a unique number. Highest common factor, HCF. Example 1. Consider two numbers, 4 and 6. The factors of 4 are 1, 2, 4. The factors of 6 are 1, 2, 3, 6. The common factors of 4 and 6 are 1, 2. The highest common factor of 4 and 6 is 2. Highest common factor is normally written as HCF. It is also called the greatest common divisor. Example 2. Consider the number 8, 12 and 16. The factors of 8 are 1, 2, 4, 8. The factors of 12 are 1, 2, 3, 4, 6, 12. The factors of 16 are 1, 2, 4, 8 and 16. The common factors are 1, 2, 4. HCF of 8, 12 and 16 is 4. Least common multiple, LCM. Example 1. Consider two numbers 3 and 4. The multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, and so on. The multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, and so on. The common multiples are ringed. These are 12, 24, 36. The least common multiple or LCM of 3 and 4 is 12. 12 is the smallest number which can be divided by both 3 and 4 without leaving a remainder. Example 2. Now consider three numbers 3, 4 and 6. The multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, and so on. The multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, and so on. The multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, and so on. The common multiples of 3, 4, and 6 are 12, 24, 36. Here again, the LCM of 3, 4, and 6 is 12. The LCM of two or more numbers is the smallest number that is divisible by each of the numbers. Test of divisibility. How will you test if 6504 is divisible by 5? Dividing 6504 and finding out if the remainder is 0 will take some time. If you remember some simple rules, you can test for divisibility very quickly. Divisibility by 10. 10 into 2 is equal to 20. 10 into 5 is equal to 50. 10 into 12 is equal to 120. 10 is the divisor of 20, 50, 120. What do you notice? A number is divisible by 10 if it has 0 in its ones place. Divisibility by 5. 5 into 2 is equal to 10. 5 into 3 is equal to 15. 5 into 6 is equal to 30. 5 into 7 is equal to 35. 5 into 12 is equal to 60. 5 into 15 is equal to 75. 5 is a divisor of 10, 30, 60, 15, 35, 75. A number is divisible by 5 if it has 0 or 5 in its ones place. Divisibility by 2. 2 into 2 is equal to 4. 2 into 4 is equal to 8. 2 into 12 is equal to 24. 2 into 16 is equal to 32. 2 into 23 is equal to 46. 2 into 25 is equal to 50. 2 is a divisor of 4, 8, 24, 32, 46, 50. Notice that these numbers have 0, 2, 4, 6 or 8 in their ones place. A number is divisible by 2 if it has 0 or an even number in its ones place. Divisibility by 3. Study the following multiples of 3. 3 into 5 is equal to 15. 1 plus 5 is equal to 6. 6 is divisible by 3. 3 into 12 is equal to 36. 3 plus 6 is equal to 9. 9 is divisible by 3. 3 into 42 is equal to 126. 1 plus 2 plus 6 is equal to 9. 9 is divisible by 3. 3 into 124 is equal to 372. 3 plus 7 plus 2 is equal to 12. 12 is divisible by 3. 3 into 1246 is equal to 3738. 3 plus 7 plus 3 plus 8 is equal to 21. 21 is divisible by 3. Notice that the sum of the digits of multiples of 3 is itself divisible by 3. Work out the sum of the digits of a few numbers which are not multiples of 3. Example, 16, 124, 3527. You will find that the sum is not divisible by 3. Therefore, a number is divisible by 3 if the sum of its digit is divisible by 3. Divisibility by 4. 416 is divisible by 4. The last two digits form 16, which is divisible by 4. 2088 is divisible by 4. The last two digits form 88, which is divisible by 4. 32,896 is divisible by 4. The last two digits form 96, which is divisible by 4. 3462 is not divisible by 4. The last two digits form 62, which is not divisible by 4. Therefore, a number is divisible by 4 if the number formed by its last two digits is divisible by 4. Divisibility by 9. 13,464 is divisible by 9. 1 plus 3 plus 4 plus 6 plus 4 is equal to 18, which is also divisible by 9. 43,256 is not divisible by 9. Is 4 plus 3 plus 2 plus 5 plus 6 is equal to 20 divisible by 9? No. A number is divisible by 9 if the sum of its digit is divisible by 9.